Okay, we are now going to talk about naming ionic compounds. So, for this section, there's two main objectives. The first one is being able to identify an ionic compound. Okay. So, we're trying to identify a compound as ionic based on its formula, its name, and or its properties. We're going to talk about what those are in just a second. The second thing we need to be able to do here is to translate between the name and formula of the compound. What I mean by that is the name may be sodium chloride, and then the formula would be NaCl. So the name are the words, and then the formula is what lots of times you all will call the abbreviation for it. Okay, this is the chemical formula for that. New vocabulary, we're going to talk about an ionic compound formula, which we just mentioned. Subscripts, which we've talked about previously, but we want to make sure that we're comfortable with those terms, and then polyatomic ions. So that's going to be our initial focus here. So very first thing, let's talk about some properties of ionic compounds. So the very first thing is that they occur between cations and anions. Now, not always, but this is usually a metal and nonmetal. Okay. So the most accurate statement is that they occur between cations and anions, but lots of times people will just say metals and nonmetals. There's some exceptions to when this is true, but generally, based on what we learned in the previous topic, with our metal ions being cations and our nonmetal ions being anions, that kind of follows that trend. When we are writing these, regardless of if it is in a formula or in a name, you always write the cation first. That's the one that's positive, remember? So sodium is our positive ion up here. So sodium is first both in the name and in the formula. Ionic compounds generally have high melting or boiling points. And what that means is it usually takes longer for these to melt or boil because it has to take in more heat. So and if we get to do the comparison lab between ionic compounds and covalent compounds, you'll see that when we test salt. Now, in general, these are, solids at room temperature. So that makes it a little bit easier for us to work with. And then the very last thing, and again, if we get to do that lab, you'll see that, is that ionic compounds generally conduct electricity when dissolved in water. Think about charges. You think about a battery. There's a positive end and a negative end to a battery. And if we're looking at our compound, there's a positive ion and a negative ion. So those charges are going to help us be able to conduct that electricity, to light a light bulb, things like that. So again, if we get to do that lab, you will see that. Okay, so method for naming ionic compounds with pattern metals. So let's remember pattern metals. This is group 1, 2, and 13. And our method for that is going to be our metal name plus our nonmetal root word with IDE. Now I already actually did this one right above. So NaCl, that's sodium chloride. Na2O, we'll talk about why we have that subscript of 2 in just a second, but let's just look at the name. So Na is still sodium. My root word for oxygen is ox, and I need to add my IDE. If you need to remember your root words, flash back to that last section where we did our non-metal naming of our ions, and that's going to help you out with that. Ca is calcium. Bromide. We're doing our root word plus IDE. So my bromine becomes bromide. Go ahead and pause the video and try these 4 over here and see how you're doing with those. Remember, we are not needing to put the word ion here because now it's in a compound. So it's no longer just an ion. So we can leave that word out. Okay. So give these 4 a try. Awesome. Let's go ahead and check those out. So Mg is magnesium. Chlorine, we're going to use our root word plus IDE, and that is chloride. Li is lithium. O is our oxygen. We're going to take our root word and IDE, so that's oxide. Sr, remember, look at your periodic table. Sr is right here, strontium. Then fluorine, we're going to make that our root word plus IDE, which is fluoride. Please remember, we're not spelling flour right here, fluoride, so watch your spelling. That's one of the things when you take your quiz or test, spelling matters. So use your periodic table, take advantage of those resources there. And then Ki, K is potassium. In I, we're going to take iodine, take our root word plus IDE, and we end up with iodide. Awesome. So now you have named with pattern metals. Let's talk about naming with non-pattern metals. So remember, non-pattern metals are our transition metals in group 14. Let's see what color we want to use here. So our method for naming these is very similar to what we've just done, but we're going to put our metal name, our Roman numeral for charge. Again, if you need a reminder of what those Roman numerals are, you wrote those down on that other note sheet right there when we were talking about those Roman numerals. Plus your non-metal root word with IDE. Now, some of you may have learned the reverse crisscross method as far as determining the charge, and that works most of the time, but there's several exceptions, especially for elements that have a +4 charge, such as tin or lead or titanium. Lots of times people will get the charge incorrect there when they are reverse crisscrossing. So this is the kind of equation, quote unquote, that we use in order to calculate your charge. Now, if it's given to you already, then you don't need to calculate it. But if it's in a compound and you need it to be able to write the name, so if it gives you the formula and you need to be able to write the name, this is a process you need to be able to do. So let's check this out. We have our number of metal ions. And then we're going to put an X for our charge. Plus our number of nonmetal ions. Then we're going to put our nonmetal, I put NM for nonmetal, charge. And then we're going to set that equal to 0. For right now, we're only working with neutral compounds, so we are going to make those charges equal out. So that's why we're able to put that 0 there. Now there's some exceptions for this, and I didn't leave you a little spot. The exceptions for this, you can see part of them on the back of your periodic table. If there's only a single charge, then that's our one and only option. So we do not need a Roman numeral for those charges. Okay. So steps for naming compounds with pattern metals. We're going to look at writing our metal name. We're going to calculate the charge if needed. And we're going to write our non-metal. Now the exceptions to this, as far as calculating, you'll see your 3 on the back. And that's silver, which is on the back of your periodic table, always has a +1 charge. Zinc, which always has a +2 charge. Scandium, which has a +3 charge. And cadmium, which has a +2 charge. So those are ones that do not need Roman numerals. Okay. Even though they're in those transition metals, they only have one charge option. So the reason that you're giving me that Roman numeral is to tell me what that charge is. If I already know it, you don't need to do that extra work. Okay. Let's go ahead to our next page and let's check out some examples here. So, CuBr. I personally like to go ahead and do the metal and non-metal and then calculate the charge. You're welcome to do it in the order like it prescribes, one step at a time. But I'm going to walk you through the process that I generally like to use. So, CuBr. I'm going to look at my periodic table. And the beauty of this is most of the metals you're going to be working with for non-pattern metals are right here on the back. So if you're not sure what Cu is, you can check this out. Cu is copper. Copper. It has more than one charge, so I know I'm going to need to leave parentheses. And then we're naming this non-metal the exact same way that we just did. So that bromine becomes bromide. Now for calculating our charge here, I have 1 copper, so I'm looking at my subscripts. I have a 1 copper because nothing's written down there. X for my charge. Plus 1 bromine. And then I need to be able to look at my periodic table. Say, okay, bromine is in group 17. Group 17 has a -1 charge. If you need some support there, some flashbacks, check out that first page of these notes, and it has the whole ion formation written down. So our bromine has a -1 charge, and this is set equal to 0. So I end up with X plus -1 equals 0. So X equals 1. So my copper is copper 1. Let's check out this next one. Fe, that's iron. We know that it can have more than 1 charge. It tells us that on the back of our periodic table. So I'm going to leave a place for my Roman numerals. And S, remember that's sulfur, so for this we're going to have sulfide. That tells me that it is an ion. So let's calculate our charge here. I have 1 iron, X for my charge, plus 1 sulfur. Let's check out our periodic table. Sulfur is in group 16, so sulfur has a -2 charge. Set that equal to 0, so I have X plus a -2 equals 0. So my charge on this iron is a 2. And again, I do not care if you write your Roman numerals with the lines on the top and bottom or just solo, as long as I can tell what the Roman numeral is. Now let's check out this next one, Pb. A lot of people always forget what Pb is. But again, since we know these are non-pattern metals, we can check out on the back of our periodic table. And Pb is right here, so we have lead. You could see it had more than 1 charge, so we're going to leave a place for our Roman numerals. And then that oxygen is going to become oxide. Let's calculate that charge there. So Pb, I don't have any subscripts. So 1 X for my charge, plus this time I have 2 oxygens. My subscript there is a 2. So I'm going to say 2. When I look at my periodic table, oxygen is in group 16. So I have a -2 charge there. And we're going to set that equal to 0 because this compound as a whole has no charge on it. So that's X plus a -4 equals 0. So I know that this lead has a charge of 4. Remember, in Roman numerals, that's 1 before 5, IV. And let's check out this last example before you move on and try some on your own. So Cr, I can look at the back of my periodic table again. Well, there we go. So that's chromium. Chromium has more than 1 charge, so I'm going to need my Roman numerals. And then that S, that sulfur, is going to become sulfide. And now I need to calculate my charge here. So I have 2 chromiums. Then I'm going to put an X for my metal charge because I do not know it yet. Plus, I have 3 S's, 3 sulfides. And when I look at my periodic table, the charge for my sulfur or sulfide is -2 because I'm in group 16. So I have 2x plus -6 equals 0. So I'm going to add 6 to both sides. So I end up with 2x equals 6. Then I need to divide both sides by 2. So x equals 3. So my final name for that one's going to be chromium 3 sulfide. Take just a second and try the 4 on the your turn. Okay, let's give these your turns a shot. So Cr we had just said was chromium. So we know it needs Roman numerals here. And then my oxygen becomes oxide. Let's check out our calculation. So I have, looking at my subscripts, 1 chromium, an X because I don't know the charge, 2 oxygens. And when we look at our periodic table, oxygen is in group 16, so it has a -2 charge there. And I'm going to set the whole thing equal to 0 because this has no charge on the compound. So I have X plus a -4 equals 0, so X equals 4. So this was chromium 3, this one was chromium 4. So both chromium, but they're bonding differently because they have different charges. They've lost a different number of electrons. Now let's check out this one. Ti. Be careful here because people love to put Ti as 10. If you look at Ti, it is actually titanium. So be careful with that. It has multiple charges, so I'm going to need parentheses there. And then we're going to take fluorine, and that's going to become fluoride. Let's calculate our charge here. I have a 1 titanium, X because I don't know the charge, plus 3 fluorides. When I look at fluorine, it's in group 17. That tells me it has a -1 charge. And I'm going to set that equal to 0. So X plus -3 equals 0. So I know that this is titanium 3 fluoride. Let's check out this next one. Mn. This is one that people usually switch up previous to this. So Mn is down here at the bottom. It is not magnesium. It is manganese. So be careful with that one. It does have more than 1 charge, so I'm going to put my parentheses. And then N, nitrogen, is going to become nitride. So again, right now we're focusing on the metal name in Roman numeral because our non-metal process has not changed yet. It's still saying the same way. So let's do our calculations here. I have a 1 magnesium, or sorry, see, I just did it. 1 manganese, X, because I don't know my charge, plus 1 nitrogen. When we look at our periodic table, nitrogen is in group 15. That means it gained 1, 2, 3 electrons. So I have a -3 charge there. And we're going to set that equal to 0. So I have X plus -3 equals 0. So this is manganese 3 nitride. Let's check out this last one on here. Hg. So if I'm looking at the back of my periodic table, Hg tells me that it's mercury. It has more than 1 charge, so I'm going to put a place for my Roman numerals. And phosphorus becomes phosphide. And let's do our calculation here. So we got 3 mercuries, X, because I don't know the charge, plus 1 phosphide. When I look at my periodic table, I can see that phosphorus is in group 15. Okay. So it needs 1, 2, 3 more electrons to have its octet. So we got a -3 charge. So 3x plus -3. So 3x equals 3. X equals 1. And again, without lines or with lines, don't care which one. And that is naming pattern metals and non-pattern metals in binary ionic compounds, meaning that there's only 2 things there.